Chapter 6, Section 1-2, Limestone of Tilgate Forest. The strata that form the subject of the following observations possess a high degree of interest and constitute one of the most important series of deposits in this part of the kingdom. The nature and variety of their organic remains, and the general resemblance which they bear to those of the Purbeck limestone and Stonesfield slate, have led me to an assiduous investigation of their history. I have, however, to regret that the distance of my abode from the tract of country in which they are situated has presented serious obstacles to an accurate determination of their geographical dimensions. But I have spared neither pains nor expense to obtain a general knowledge of their fossil remains and geological relations. And as these strata are of inconsiderable extent, and hold an indeterminate situation between the iron sand and the wheeled clay, appearing to repose upon the former, it seems probable that they are either a local deposition formed in an excavation or basin of that deposit, or a protrusion of the Purbeck beds which lie beneath it. Without, however, deciding in favor of either supposition, it has been thought expedient to describe these strata in a separate section, and for the present to distinguish them by a term derived from the central locality of the area they occupy on the surface. The strata of Tilgate Forest consist of various layers of sandstone, limestone, and calcareous slate, lying on a bed of blue clay, of very considerable thickness. Advancing from the downs on the Brighton road, the outcrop of the sandstone is first seen near Taylor's Bridge, and it subsequently appears on the margin of the stream that winds along the foot of Cuckfield Park, a quarter of a mile south of the town. At this spot an excavation has been made, which exposes to view a perpendicular rock of sandstone about 20 feet high. The strata are nearly horizontal, and vary from 1 to 5 feet in thickness. The hill, on the southern slope of which the town of Cuckfield is situated, is also composed of this formation, and in a field adjoining the churchyard, the sandstone is seen lying beneath a thick layer of diluvial aggregate, and containing subordinate beds of limestone. From the cultivated state of the country and the quantity of loam and vegetable soil, I have been unable to trace the outcrop of these deposits with the requisite degree of accuracy. In a northerly direction they extend from Cuckfield through Handcross and Tilgate Forest to Crawley, and on the northwest probably as far as Horsham and St. Leonard's Forest. Eastward I have not noticed them beyond the vicinity of Linfield, but it must be acknowledged that from the causes already mentioned, their geographical extent is but imperfectly known. On the line of road extending from Hickstead to Crawley, several quarries have been opened for obtaining the stone for architectural and other economical purposes, and in these excavations the strata may be examined with facility. In the sections that were accessible to observation, some variations were noticed in the composition and relation of the beds, but these were neither constant nor important, and the entire series is readily identified by the extraordinary character of its organic remains. The following section is the result of numerous observations, and may be regarded as the order in which the strata generally occur, commencing with the lowermost deposit. Section of the strata of Tilgate Forest. 1. Blue tenacious clay destitute of organic remains, and of an indeterminate depth. In this bed water occurs at the depth of 30 or 40 feet. 2. compact limestone of a bluish-gray color, separated by seams of indurated blue marl into layers from 3 to 12 inches in thickness. It forms a bed about 9 feet thick and contains the bones of 2 species of turtle, of 1 or more species of crocodile or monitor, and the remains of vegetables allied to the Euphorbiae. The upper strata are a compact conglomerate. The lower are perfectly homogeneous, and where in contact with the clay, contain shells of the genus Vivipara. 3. Yellowish sand and soft calcareous sandstone, alternating with thin layers of compact limestone slate, containing bones of crocodiles, of some unknown animals, and of birds, bones and plates of 2 species of tortoises, carbonized wood, remains of vegetables resembling the Euphorbiae, arborescent ferns, gigantic reeds, and casts of univalves and bivalves, etc. This bed is about 7 feet thick. 4. Diluvial aggregate, composed of quartz pebbles and rounded fragments of chalk, limestone, and sandstone, loosely united by a coarse grit. It contains immense quantities of minute portions of bone rounded by attrition, teeth of fishes, and of lacertae, thickness from 3 to 6 feet. 5. Vegetable mold and loam from 1 to 3 feet thick. In this enumeration of the strata, those fossils only are mentioned which appear to occur most frequently in the respective beds, since the organic remains are distributed indiscriminately throughout the whole series of deposits, although certain of them are more abundant in one stratum than in another. The limestone number 1 is exceedingly compact and offers great resistance to the hammer. It scintillates with steel, effervesces strongly with acids, and varies considerably in purity. The upper part of the rock is a conglomerate of a mottled appearance, exhibiting various shades of blue, white, and grayish-green. It is composed of quartz pebbles and irregular fragments of limestone and bones, embedded in a calcareous gangue, and is interspersed with crystallized carbonate of lime. The quartz pebbles appear to be of chemical origin, and not derived from the ruin of other strata. The indeterminate layers are a pure bluish-gray, or greenish limestone, in texture and appearance very much resembling the finer beds of the Swindon stone. The inferior layers are very analogous to the Purbeck limestone, and where in contact with the clay, contain remains of the same kinds of testisae. The bed is traversed by thin veins of calcareous spar of a light amber color, and this substance generally occupies the fissures in the wood, bones, and other organic remains, forming groups of tabular and lenticular crystals in the cavities of the limestone. It also contains small nodular masses of carbon and charred wood. Every kind of fossil that has been discovered in the strata of Tilgate Forest occurs in this bed, namely bones and teeth of the gigantic monitor or crocodile, bones and plates of turtles, teeth of fishes, leaves and stems of Euphorbiae, casts of univalves and bivalves, etc. The sand and sandstone, number 3, vary from a light fawn color to a deep brown, and in some parts are highly ferruginous. The sandstone is soft and friable, and alternates with thin layers of calcareous slate. The latter is compact, but readily separates into thin flakes, and these are divided by the workman into slabs, from 1 to 1.5 feet square, which are used for roofing in that part of the country. The surface of this slate presents a most extraordinary appearance, being everywhere marked with undulating furrows, so strikingly resembling the impressions made on the sand of the seashore by the action of the waves, that I cannot but regard them as the result of a similar operation. The sandstone contains the teeth, vertebrae, and bones of the crocodile, and large portions of the stems of vegetables allied to the Euphorbiae and Dixoniae, besides others which are in too imperfect a state to admit of their characters being determined. The slate abounds with the carbonized foliage of unknown plants, carbonized wood, and casts of univalves and bivalves. Carbonate of lime in lenticular crystals sometimes occurs between the separations of the strata, and rounded quartz pebbles in the blocks of sandstone. The aggregate, number 2, is evidently diluvial. It lies in horizontal layers, immediately beneath the vegetable mold, and varies from 1 to 6 feet in thickness. It is of considerable extent, and there is scarcely any inequality of the surface, in the immediate vicinity of Hickstead, Crawley, etc., where it is not exposed to view. In the upper part of the bed, the chalk, limestone, sandstone, and quartz pebbles are reduced to the size of small grains, and the bones, teeth, and other organic remains have suffered an equal degree of comminution. In the inferior layers, they are considerably larger, and the chalk and quartz pebbles less frequent. The chalk appears to have undergone but little change, except that it has acquired considerable hardness, probably from an infiltration of crystallized carbonate of lime. The quartz pebbles exhibit their usual characters. They are slightly translucent, and being rubbed against each other, emit a strong electric smell, with a stream of light at the line of collision. This accumulation of water-worn materials is loosely united by a fine grit, apparently formed by the farther disintegration of the same substances. The organic remains contained in it are, with but few exceptions, reduced to very small fragments, which offer but slight indications of their original form. The teeth and scales are the most perfect, their superior hardness having enabled them in some measure to resist the action of the water. Of these, the molar teeth of the Anarhicus lupus are the most abundant. The teeth and scales of the monitor or crocodile, and the bones and plates of a species of tortoise, are occasionally found in it, and also the triangular striated tooth, number 14, and the teeth of a species of squalus, number 13. We shall now proceed to a more minute examination of the organic remains of these remarkable strata, and by comparing them with the recent genera and species to which they appear most nearly related, endeavor to obtain some idea of the form and structure of the originals. Organic remains of the strata of Tilgate Forest. Vegetable remains. These occur either in the form of carbonaceous impressions in the limestone, slate, and carstone, or consist of sandstone casts of a ferruginous color, bearing the form and external characters of the original. 1. Wood. In the state of carbon or charcoal, still retaining its ligneous structure. The fissures in its substance are filled, in some specimens, with white calcareous spar, and in others with pyrites of a brilliant appearance. The latter quickly undergo decomposition by exposure to the air. It occurs in small portions, which are generally embedded in the more compact masses of carstone. 2. The stems or culms of vegetables allied to the Euphorbiae, or to some species of arborescent fern, perhaps Dixonia? The surface of these fossils is rough, being covered with oblong irregular tubercles, disposed in longitudinal undulating lines. The trunk is nearly cylindrical, but somewhat compressed, and is contracted at irregular intervals, in some specimens exhibiting rudiments of branches. The nearest are nearly 14 inches in circumference, and upwards of 4 feet in length, and from the imperfect state in which these occur, it is evident that the originals attained a very large size. Sections show no traces of the internal structure. They are associated with impressions of leaves and other vegetal remains, but my distance from the quarry has prevented me from ascertaining the relation they bear to each other. They are principally found in the sand and sandstone, and are covered with a ferrigno-carbonaceous crust, which falls off when the surrounding matrix is removed. I am unacquainted with any vegetables, either recent or fossil, with which these remains can be identified. They bear some analogy to the Phytolithus plantites vericosus of Martin, but differ in the superficial markings, and are destitute of the imbricated body observable in the Derbyshire fossil. They agree in their general conformation with the Euphorbiae of the East Indies, but at the same time present differences sufficiently remarkable to prove their want of identity. In all probability, they are casts formed in the cavities of the stems of arundinaceous plants, the crust with which they are invested being the remains of the cortical covering of the original. (3) A cylindrical imbricated body, marked with interrupted longitudinal striae, the medullary or internal part of a vegetable, analogous to the fossils last described. It is composed of sandstone, and occurs in fragments of a foot or more in length, and from 6 to 8 inches in circumference. 4. A hollow cylindrical body, slightly compressed, the cortical or epidermal remains of a vegetable. This fossil is 2 inches and a half long, 12 inches in circumference, and 1 inch in thickness. The external surface is divided into compartments of a rhomboidal form by deep cancellated sulci, and the internal is marked with interrupted longitudinal striae, apparently the impressions of a body which it formerly enclosed. This specimen is decidedly the remains of the epidermal covering of a plant, and very probably of the same kind as the fossil No. 3, the markings on the external surface of the one, and the impressions on the interior of the other, perfectly corresponding. In its structure it approaches to Plantites vericusos of Martin, but its external surface more nearly resembles that of Phytolithus plantites. Phytolithus plantites imbricatus. It is, however, essentially distinct from either. It is probably part of an unknown species of palm or arborescent fern. Mr. Koenig observes that some arborescent Dicksonias are very like it with regard to the lozenge-shaped bases of the fronds or leaves. This specimen is from the sandstone, and is the only one hitherto discovered. (5) A compressed, clavated culm or stem of a plant, the surface possessing a leafy structure, and having numerous tortuous sinuses that pass into the substance of the fossil. A transverse section, 3 inches in diameter, exposed 35 openings produced by this cause. These fossils occur in fragments from a few inches to several feet in length, and some of them attain a considerable magnitude, being upwards of 2 feet in circumference. They are of an irregular club-like form, having a very narrow base, and are invested with a thick carbonaceous covering, removable by washing. Their constituent substance is a hard limestone of a light ash color, interspersed with druzy crystals of carbonate of lime. They are found associated with the fossil vegetables previously noticed, but are of more rare occurrence. The internal structure of these petrifications resembles that of many succulent plants, and in their outward form they so nearly approach the euphorbiae that it may be presumed they are the remains either of an unknown species of that genus, or of one very closely allied to it. 6. Impressions and remains of the foliage of unknown vegetables, in a carbonized state, lying in confused masses in the carstone and limestone shale. So far as their form can be distinguished, some of the leaves appear to be of an ovate and others of a lineary lanceolate shape, but they are too imperfectly displayed to admit of accurate determination. In some respects they resemble the foliage of the Derbyshire phytolite pet derb, Table 12. And as they are associated with the supposed euphorbiae, it seems probable that the stems of the latter were furnished with leaves, of which these are the remains. 7. The impressions of leaves of a species of carex or sedge, perhaps iris. These are frequent in the form of reddish-brown stains and impressions. Similar remains also occur in the Stonesfield slate. Fossil shells. These, with but one exception, occur only in the state of casts or impressions, and their characters are so imperfectly defined that it is scarcely possible to ascertain the genera and species to which they belong. 8. Vivipara fluviorum, perhaps Paludinae. These are apparently similar to the shells of the Petworth marble, figured in Tablet 17, figures 5 and 6. They occupy the lowermost layers of the carstone and occur in groups of 50 or 60, disposed in relief on the surface of the stone, where the latter is in contact with the blue clay. Vivipara extensa, associated with the former. 10. Casts of spiral univalves of uncertain genera. 11. Casts of 2 species of Mia or Unio. 12. Casts of 4 species of transverse bivalves, whose generic characters cannot be determined. Some parts of the limestone contain a considerable number of these nuclei, closely invested by the surrounding matrix, no appearance of the space formerly occupied by the shells being perceptible. The surface of the casts is smooth and of a ferruginous color, spotted with stellular markings of a darker shade. Remains of fishes. The teeth and perhaps the scales are the only parts of fishes that have been found in these deposits. The former, from their hardness and durability, are in an excellent state of preservation, retaining their original sharpness of outline, with their natural polish, heightened and improved by mineralization. Their color is a dark chocolate, inclining to black, apparently produced by an impregnation with oxide of iron. They are exceeding brittle, and have their cavities filled with the substance in which they are embedded. 13. A triangular tooth of a species of squalus or shark, resembling in form the specimen represented Figure 9, Plate 19, Volume 3, Organic Remains, but much smaller. It occurs also at Stonesfield, near Oxford. 14. A triangular tooth with two lateral processes, the surface longitudinally striated, length 0.2 inch. Mr. Parkinson has figured a similar fossil from the Old Passage, Gloucestershire, but does not offer an opinion as to what animal it originally belonged. 15. Molar teeth of the Anarchus lupus. These are of a semi-orbicular form, sometimes slightly acuminated, from the size of a millet seed to 0.5 or 0.6 inch in diameter. They possess a beautiful polish, and are called fish's eyes by the workmen. I have compared these fossils with the molar teeth of the recent A. lupus or sea wolf, and could not perceive the slightest difference either in their form or structure. They are frequently worn nearly flat, probably from the mastication of hard substances, as the recent fish preys on crustaceous and testaceous animals. In one specimen, 20 of these bodies are attached to a small block of limestone. They are very abundant in the alluvial aggregate, and are found in the Stonesfield slate. 16. Scales of a lozenge shape, an inch long, and 3/4 of an inch wide, having bifurcated processes of attachment. These scales are very thick, and of a glossy black color. The process of attachment is of a pale brown, and of a bony or perhaps cartilaginous structure. Although in conformity with the opinion of others, I have been induced to consider these fossils as belonging to an unknown fish. Yet I entertain some doubts if they may not, with greater propriety, be referred to an animal of the lizard tribe. Remains of oviparous quadrupeds. These consist of the bones and plates of several species of tortoise, and the scales, teeth, vertebrae, and other bones of one or more species of crocodile. Fossil tortoises. The remains of these animals in my possession clearly point out the existence of 3 species in the Tilgate beds. The first, in the form of its plates, resembles the Testudo midas, esculent green turtle, of Linné, Testudo viridis of Schneider, and must either have belonged to the same species or to one very analogous to it. Of this kind I have the following specimens. 17. 3 detached plates on a block of carstone, resembling the plates on the left side of the tortoise of St. Peter's Mountain. Foyas, Plate 14. 2 of these are mutilated, but the other is nearly perfect. It is of a quadrangular form, measuring 2.4 by 2.7 inch, and its edges are slightly dentated. 18. A specimen 6 inches long and 2 wide, composed of 3 united dorsal plates. 19. Dorsal plates with rudiments of the ribs. These fossils are evidently of the same species as the turtles found at Mellsbrook. It may be proper to remark that the recent species above mentioned is an inhabitant of the coasts of the islands and continents of the torrid zone. 20. Of the second species of Testudo, I have but a few imperfect plates, yet their structure is so well displayed as to leave no doubt of their being distinct from those previously described. Their surface is covered with numerous little pits or hollows, irregularly disposed, and which served in the recent state to render the soft integument of the animal more adherent. The specimens in my possession resemble the plate from the Paris basin, figure 1, Fossile de Paris, Reptiles et Poissons, described by Cuvier, and referred by that illustrious naturalist to the subgenus Trionyx of Mr. Geoffroy, a division that contains freshwater species only. 21. The existence of a third species is presumed from a plate, to which a portion of the rib is still attached. Mr. Clift of the Royal College of Surgeons, who did me the favour to compare it with the recent turtles in the museum of the college, remarks that this fossil resembles the third rib from the neck of a species allied to the hawksbill turtle, Testudo imbricata, which inhabits the American and Asiatic oceans. The rib is longitudinally striated and precisely similar to the specimen from Melsbrook, figure E, planche 5 of Burton. Of the bones of the testudines, I have obtained the following, and probably several others, which at present I am unable to distinguish from those of other animals. 22. Part of the omoplate or scapula, Cuvier, Tome 4, Plate 2-5b. 23. Part of the clavicle, Cuvier, Tome 4, Plate 2-5d. My excellent friend Mr. Lyell informs me that the remains of several species of testudo have been discovered at Stonesfield, and that some of the plates which he saw resembled the first species above enumerated. The circumstances mentioned here to point out the remarkable correspondence that exists in the contents of these deposits. Fossil lacerti. The teeth, vertebrae, bones, and other remains of an animal of the lizard tribe, of enormous magnitude, are perhaps the most interesting fossils that have been discovered in the county of Sussex. The teeth and scales, like those of the fishes, are generally well preserved, but the bones have sustained considerable injury from fracture and attrition, which renders the determination of their osteological characters exceedingly difficult. Of the numerous specimens in my collection, not one is perfect, by far the greater part consisting of fragments rounded by the action of water, and deprived of those anatomical distinctions so essentially necessary to the elucidation of the form of the original. They are heavy, brittle, of a deep brown color, and strongly impregnated with iron, and when exposed to the action of the blowpipe, evince unequivocal proofs of their animal origin. Their cellular structure is sometimes beautifully displayed, being injected either with limestone or crystallized carbonate of lime, and in numerous specimens the medullary cavities of the long bones are filled with white, semi-transparent, calcareous spar. The vertebrae are the most entire, but even these have their bodies more or less compressed, and their processes broken or altogether destroyed. But notwithstanding the mutilation these remains have undergone, their osteological characters are still sufficiently marked to denote not only the genus of the animal to which they belonged, but also to afford some slight indication of its species. The following are the most illustrative specimens in my possession, and from which the suggestions hereafter offered concerning the nature of the original are principally derived. 24. Teeth of a conical form, slightly curved, their surface covered with numerous longitudinal ridges or striae, which converge towards the apex. The superior terminations are acuminated in some examples, and rounded or obtuse in others. These fossils are either round or somewhat compressed, and vary considerably in size and curvature. They are from 0.2 inch to 3 inches long, and from 0.3 inch to 2.8 inches in circumference at the base. The upper part only is striated, the lowermost half being perfectly smooth. With but few exceptions, they consist of the crown of the tooth only, appearing as if broken off close to the jaw. And although in a few instances part of the fang remains, yet the detached state in which they are found prevents their mode of insertion from being accurately determined. The fangs are hollow like those of the crocodile, but the presence of younger teeth within the cavities of the older ones, as in that animal, has not been detected. The teeth possessing the characters here enumerated constitute the following varieties, but whether they originally occupied different situations in the jaws of the same species, or belong to different species of the same genus, cannot at present be determined. Variant A, nearly cylindrical, diminishing very gradually towards the apex, which is obtuse. This variety is represented by Lude, figures 1318 and 1319. The largest specimens are of this kind. Variant B, a slender, delicate tooth, rather compressed, curvature gradual, apex slightly acuminated. Mr. Clift, who examined a tooth of this species, observes that there can be no doubt of its having belonged either to the crocodile or monitor. I know of no other animals whose teeth have the lateral ridges so strongly defined. I have several teeth of this kind from Stonesfield, collected by Mr. Lyell. Variant C, a slender tooth, nearly straight, very similar in form to the teeth in the anterior part of the jaw of the Gavial or Gangetic crocodile. 25. Scales of an irregular rhomboidal form, exceedingly thick, with one extremity sharply pointed. These are associated with the teeth above described, and perfectly resemble the scales of the recent alligator in Exeter Change. Vertebrae. These differ from each other in the number, situation, and form of their processes, which vary according to the situation the vertebrae respectively occupied in the spinal column. In their general characters they resemble those of the crocodile, from which, however, they are separated, in having both faces slightly concave. A similar structure has been noticed by Cuvier in the vertebrae of an unknown fossil crocodile, discovered at Havre and Honfleur, and it is to this species that the osseous remains of the Tilgate beds most nearly correspond. The vertebrae are of three kinds, namely dorsal, lumbar, and caudal. The cervical have not been discovered. 26a. Dorsal. The most perfect specimen resembles the vertebrae delineated by Lude, figure 1607 and figure 11, plate 1 of Cuvier. Or more properly speaking, partakes of the characters of both. The body is slightly contracted in the middle and has two costal depressions, or concave articulating surfaces for receiving the heads of the ribs, fossette costale, A. B. Cuvier, loc cit, between which are two fossae, each containing a foramen. The faces are transversely elliptical. The dimensions of the vertebrae are as follows: length of the body 1.5 inch, transverse diameter of the faces 2 inches, anterio-posterior diameter 1.5 inch. The processes are wanting, but traces of the suture by which the annular part was united to the body of the vertebrae are very manifest. 27b. Lumbar. These resemble the former, except that the costal depressions are absent. They are of a large size, and must have belonged to an animal of considerable magnitude. One specimen, which is precisely similar in form to the middle vertebrae, in figure 6, Crocodiles fossiles, plate 1 of Cuvier, except that both its faces are slightly concave, is of the following dimensions. Length of the body, 5 inches. Diameter of the faces, 3.8 inches. Diameter of the middle, 2.8 inches. Like the vertebrae described by Cuvier, this specimen is more contracted in the middle than those of the recent crocodile, and it also resembles the former in having a deep fossa immediately beneath the annular part. See D. Figure 10, Cuvier-Loxit. 28C. Caudal. In these, the axis of the body is much contracted. They are of an elongated form and bear a close analogy to the vertebrae of the recent crocodile. Figure 7, Plate 2, Os séparés de crocodile, Cuvier. One of the most interesting specimens in my possession has the remains of the spinous and articulating processes. Length of the body, 3 inches. Diameter of the middle, 1.2 inches. Diameter of the faces, 1.4 inches. The agreement between the vertebrae here described and those of the fossil crocodile of Honfleur is so striking as to leave no doubt in my mind of their identity. This opinion is confirmed by the nature of the other bones entombed in the same deposit, and which we shall now proceed to examine. Of these remains, the ribs are the most perfect, and their osteological characters are decidedly analogous to those of the lizard tribe. The following are selected as the most illustrative examples. 29. Part of a rib, with the vertebral extremity remaining. The head of the rib and the tubercle by which it was attached to the transverse process of the vertebrae are broken off, but the situation of these parts is sufficiently indicated to prove the resemblance of the specimen to the vertebral end of the ribs of the crocodile. Plate 2, Figure 4, K.I. Os séparés de crocodile, Cuvier, Book 4. 30. A rib 21 inches long, with both extremities destroyed. The sternal end is transversely elliptical and about 2 inches in circumference. The bone gradually increases in width towards the opposite extremity, where its inner surface becomes nearly flat, and the outer slightly ridged. The width of this portion is equal to the circumference of the sternal end. Fragments of ribs of this kind occur also at Stonesfield. From the mutilated state of the following specimens, the references to Cuvier's figures of the bones of the recent crocodile are probably in some instances erroneous. They may, however, for the most part be regarded as nearly approximating to correctness. 31. Portion of the sternal end of the clavicle. Figure 10, Plate 2. Os séparés de crocodile, Cuvier, Book 4. 32. Head of the radius. B. Figure 13, Plate 2. 33. Carpal extremity of the radius. B. Figure 13, Plate 2. 34. Part of the os pubis. C. Figure 15, Plate 2. 35. Fragment of the os ilium. A. Figure 15, Plate 2. 36. Lower extremity of the femur. B. Figure 12, Plate 2. Some fragments of a cylindrical bone, probably the femur, indicate an animal of a gigantic magnitude. I have specimens from 10 to 27 inches long and from 11 to 25 inches in circumference, the substance of the bone being more than 2 inches thick. Some examples have large foramina for the passage of blood vessels. 38. Lower extremity and other portions of the tibia. Figure 11, Plate 2. 39. Fragments of the metatarsal bones. Figure 16, Plate 2. From the facts that have been presented to our notice, We may with confidence conclude that the remains in question belong to an animal, approaching in its osteological characters to the crocodile, or perhaps to the genus Monitor of Cuvier, but differing in many important particulars from the recent species. That they are precisely similar to the bones of the second species of fossil crocodile discovered at Honfleur, and which Cuvier considers as an extinct animal, related to the gavial or gangetic crocodile. Lastly, that this species exceeded in magnitude every animal of the lizard tribe hitherto discovered either in a recent or fossil state. Teeth and bones of unknown animals. Associated with the remains of the monitor and turtles above described are several teeth and bones, whose characters are too obscure and uncertain to admit of determination, without the aid of more illustrative specimens. A brief description of these fossils is here inserted, not in the hope of being able to elucidate their nature, but to record their existence in the Tilgate beds with a view to future inquiries. 40. Teeth. Among these are several incisors and molars that have evidently belonged to the same kind of animal. They are of a very singular character, and differ from any previously known. The molars are of an irregular pentagonal form, their sides channeled and obscurely striated. The masticating surface is perfectly smooth, and rather depressed in the center, and in the largest specimen is 0.8 inches long, and 0.5 wide. They consist of the crown of the tooth only, and are perfectly solid. An incisor tooth that appears to correspond with the preceding is 1.3 inches long. It is slightly bowed, and nearly smooth on the inner surface, but externally has a longitudinal ridge which extends down the front. The crown of the tooth is 0.6 inches long and 0.4 inches wide. Its sides are angular, and their edges finely crenated. 41. An incisor tooth of a cuneiform shape, 1.1 inches wide and 1.4 inches long. The crown only remains. When perfect, this specimen must have been of a very considerable size. Several smaller examples were discovered by Mrs. Mantell in the diluvial aggregate. 42. A curved tooth much compressed, the surface smooth, the apex obtuse, and the edges serrated. The external margin is thick and rounded. The inner edge thin and acute. Length 1.5 inches. This specimen resembles figure 1328 of Lude, but does not entirely correspond with the figure of that author. A reference to it will, however, serve to render this description more intelligible. The teeth near the front of the lower jaw of the barracuda are very similar in form. 43. Part of the scale of a fish? It is half an inch square, and its surface covered with irregular depressions. The markings on its surface resemble those of the dorsal scales of the sturgeon. Accipenser sturio. May it not have belonged to a species of Trionyx? 44. Part of the lower jaw of a fish? Or of an animal allied to the monitor? Embedded in a block of limestone. This interesting specimen is in the possession of my friend R. Weeks, Esquire of Hurtpur Point. It is part of the right side of the lower jaw, about 1.6 inches long. It contains 7 slender, curved, pointed teeth, the largest of which is 0.2 inches long. Mr. Koenig, to whose notice it was submitted, thought it belonged to an animal allied to the monitor. 45. Portion of a rib slightly curved and nearly flat. Length 14 inches, width of the narrowest extremity 2.5 inches, of the widest 3 inches, thickness 0.8 inches. This specimen bears a greater resemblance to the rib of a quadruped than to those of the Lacerti. From this sketch of the strata and organic remains of the Tilgate strata, imperfect as it may be, several important inferences naturally arise. But as my information concerning these remarkable deposits is too limited and uncertain to warrant any general conclusions, I shall not at present presume to attempt an explanation of the phenomena they exhibit, but conclude with a brief recapitulation of the facts which this investigation appears to have established. 1. The country in the environs of Tilgate Forest is composed of various beds of limestone and sandstone, covered with a layer of diluvial detritus, their total thickness being about 30 feet. 2. These deposits, so far as our knowledge extends, are of inconsiderable extent, occupying a district not exceeding 15 square miles. 3. They contain the remains of oviparous quadrupeds and fishes, freshwater, and marine shells, and numerous vegetables. 4. Of these remains, a few only are sufficiently entire to point out the characters of the originals, the most considerable portion being reduced to fragments, and rounded by attrition, and all more or less broken and indiscriminately mixed together. 5. The more perfect examples are referable to the following animals and vegetables, namely, an animal of the lizard tribe of gigantic magnitude, other species of lacertae, the characters of which have not been satisfactorily determined. 3 species of turtle, 2 of which are marine, and the third a freshwater species. Of the former, one is related to Testudo midas, and the other to Testudo imbricata. The freshwater species resembles the fossil turtle of the Paris basin. 2 kinds of fishes related to recent species, at present inhabitants of our seas, if not the same, namely Squalus mustulus and Anarchicus lupus. Several species of bivalve and univalve shellfish, the former belonging to the genera Mia and Unio, the latter to the genera Vivipara or Paludina, consisting of the same species as the shells of the Purbeck limestone. The vegetables resemble in their general characters certain plants peculiar to tropical regions, namely the Euphorbiae and Dicksoniae. Some of them are evidently the remains of palms and gigantic reeds, and one species is very similar to the common carex of our rivers. It results from these observations that the animals and vegetables of the Tilgate strata must have been overwhelmed by a fluid in a state of violent commotion, since they are generally broken and their fragments promiscuously intermingled. Yet from the perfect manner in which the teeth, scales, and other parts are preserved in some examples, there is reason to conclude that the originals were not transported from a distant country, but lived and died in the vicinity of the district, where their remains are now entombed. In fact, the existence of dry land at no great distance seems clearly indicated by these remains of vegetables and amphibia. Some of the former must have grown on the borders of a river or lake, and the habitats of the recent species, most nearly related to the latter, warrant a similar conclusion, since they are well known to frequent the rivers and marshy tracts of tropical regions, in the sands and banks of which they deposit their eggs. Reflecting upon these extraordinary facts, may we not inquire with the illustrious Cuvier, at what period was it, and under what circumstances, that turtles and gigantic crocodiles lived in our climate, and were shaded by forests of palms and arborescent ferns? On the geological position of the strata in the environs of Tilgate Forest. The geological position of these beds is involved in much obscurity and cannot at present be satisfactorily determined. The analogy which they bear to those of Purbeck is, however, so striking that the mind naturally assigns to both the same relative situation. Yet the latter are well known to lie immediately beneath the iron sand formation, while the strata in question are almost in contact with the wheeled clay, appearing on the surface as represented in the annexed diagram. A. Chalk of the South Downs. B. Blue chalk marl. C. Green sand. D. Wheeled clay. E. Sand. F. Tilgate beds. G. Iron sand. It is obvious from this section that the only hypothesis by which the connection of the Tilgate and Purbeck beds can be rationally explained is that of supposing them to form a protrusion through the iron sand, the relative position of the respective substances being such that a denudation or removal of the upper beds could not have occasioned their present appearance. And as the thickness of the iron sand is estimated at 500 feet, the Tilgate strata, according to this supposition, must be situated on the summit of a hillock, or peak, 500 feet above the level of the uppermost beds of the Purbeck limestone. A. Iron sand. B. Tilgate beds. C. Purbeck limestone. The discussion of this subject cannot, however, be pursued in this place without leading to the anticipation of facts hereafter to be examined. It will therefore be more convenient to reserve any farther observations to the concluding section of this volume. On the analogy between the organic remains of the Tilgate beds and those of Stonesfield, near Oxford. In the course of this inquiry, allusion has been made to the fossils of the Stonesfield slate and their general resemblance to those of the Tilgate strata. This correspondence in the organic remains of deposits, whose geological relations are so entirely dissimilar, is a fact sufficiently interesting to require some attention. The Stonesfield limestone is well known to belong to the middle beds of the oolite, and has long been celebrated for the extraordinary character of its fossils, of which, however, no detailed account has yet appeared before the public. According to Dr. Kidd, it contains crabs, birds, tortoises, and one or more large quadrupeds, and the Reverend W. Conybeare, in his highly interesting memoir on the Plesiosaurus, mentions that it also encloses the remains of an immense saurian animal, approaching to the characters of the monitor, and which, from the proportions of many of the specimens, cannot have been less than 40 feet long. With the assistance of Charles Lyell, Jr., Esquire, M.A., of Bartley Lodge, Hants, and aided by an interesting collection of Stonesfield fossils, for which I am indebted to his liberality, I have been able to ascertain that the following organic remains occur in both deposits. That is, the teeth, ribs, and vertebrae of a gigantic animal of the lizard tribe, bones and plates of several species of tortoise, teeth of a species of Squalus and Anarhicus, scales of fishes and Lacertia, bones of birds and of quadrupeds, a plant of the genus Carex, allied to recent species, but the resemblance extends no farther. The Trogoniae and belemnites of the Stonesfield slate do not occur in the Tilgate beds, and the Viviparae, Euphorbiae, etc. of the latter have not been discovered in the former deposit. It is scarcely necessary to add that the limestone slate of Tilgate exhibits no traces of oolitic structure. Very much resembling the finer beds of the Swindon stone. Swindon, near Marlborough, Wilts. The stone quarried in its vicinity is a member of the Portland limestone. Organic remains of the strata of Tilgate Forest. When the idea of this work first suggested itself, my information concerning these deposits was too imperfect for publication, and their description was in consequence excluded from the original plan. The organic remains I then possessed were but few and uninteresting, and the plates were devoted to other objects before more illustrative specimens occurred. Should circumstances permit, I shall hereafter lay before the public delineations of several extraordinary fossils recently discovered in these strata. Upwards of 4 feet in length. One of the finest specimens hitherto discovered is deposited in the British Museum. Phytolithus plantites vericosus of Martin. Phytolithus plantites vericosus of Martin. Petrificata Derbyshire, or Figures and Descriptions of Petrifications, collected in Derbyshire, by William Martin, FLS, Wigan, 1809. Tablet 11, 12, 13. Phytolithus plantites imbricatus. Petrificata Derbyshire, Tablet 14, Figure 5, and Tablet 50. This specimen is from the sandstone, and is the only one hitherto discovered. Subsequent observations have convinced me that this specimen is decidedly the epidermal covering of numbers 2 and 3, the latter being the casts of the internal part of the original. Similar remains also occur in the Stonesfield slate. It is worthy of remark that, with the exception of fragments of charred wood, the vegetable reliquae of the Tilgate limestone and sandstone consist exclusively of those which possess the most simple structure, namely the monocotyledonous or acotyledonous tribes of plants. No appearance of the space formerly occupied by the shells being perceptible. This mode of petrification is termed redintegration. See page 50, Martin's outlines of an attempt to establish a knowledge of extraneous fossils on scientific principles. 8 volumes, 1809. Macclesfield. Molar teeth of the Anarchus lupus. See Parkinson, Organic Remains, Volume 3, 19, Figure 6 and 7. Lewid, Figure 1382, 1525. Scylla, Tav 2, Fohas Hist Saint Pierre, Tablet 19. Similar to the specimen from Melsbrook, Figure E, Planche 5, of Burton. Oryctographie de Bruxelles ou description du fossile tant naturel qu'accidentel découvert jusqu'à ce jour dans les environs de cette ville par Monsieur François Xavier Bertin. Folio 1784. but the presence of younger teeth within the cavities of the older ones, as in that animal, has not been detected. In a specimen recently discovered, this structure is, however, very apparent. The anterior part of the jaw of the gavial or gangetic crocodile, on the authority of Clift, Esquire. Vertebrae delineated by Lude, figure 1607, and figure 11, plate 1 of Cuvier. Description des ossements des environs de Honfleur et de Havre. Cuvier, Animaux fossiles, tome 4, Crocodile fossile. One of the most interesting specimens, this fossil was submitted to the inspection of Mr. Clift, who remarked that it perfectly resembled the vertebra of a crocodile, except that both its extremities were concave, while those of the recent animals of that genus were concave anteriorly and convex posteriorly. The fossil crocodile of Honfleur. Two species of crocodile are found in a fossil state at Havre and Honfleur, one having its vertebrae concavo-convex, as in the recent species, and the other with both faces of the vertebrae slightly concave. It is to the latter that the bones in question are referable, a species that Cuvier considers as extinct, but which is nearly related to the gavial or gangetic crocodile. These organic remains also correspond with those of the Tilgate strata in their mode of preservation, but the bed in which they are deposited, and which I had formerly imagined might be identified with our wheeled clay, is referred by Mr. Parkinson to the blue lias of Dorsetshire. It may not be uninteresting to add Cuvier's description of the strata. After a few prefatory observations, this illustrious naturalist thus proceeds. Ils sont tous dans une banque de marne calcaire endurci d'un gris bleuâtre qui devient presque noirâtre quand il est humide et qui règne des deux côtés de l'embouchure de la Seine, le long du rivage du pays de Caux et de celui du pays de Rouge, comme au cap de la Hève, et entre Touques et Dives, vis-à-vis les vaches noires. Il s'élevait en quelques endroits au-dessus du niveau de plus haute marée et dans d'autres il est recouvert par les eaux de la mer. Il recèle partout des outres, des petites moules et des petites télines discoides d'espèces particulières, et les os eux-mêmes ont des huîtres et des tuyaux de serpulles adhérents à leur surface. Mais il n'est pas assez de dire si ces coquilles y tenaient déjà avant qu'ils en sont été enveloppés par la marne, ou si elles ne s'y sont attachées que depuis que la mer les a lavées et mises à découvert. Quant à ce banc de marne, il est certainement plus ancien que la masse immense de craie qui repose sur lui et qui s'élevant en falaise de 3 et 400 pieds de hauteur, forme tout le pays de Caux, une partie du pays de Auge, et s'étend en Picardie, en Champagne et jusqu'en Angleterre. La substance des os est d'une brune très foncée et prend un beau poli. Les acides la dissolvant et en prenant une teinte rougeâtrée qui annonce qu'elle est colorée par le fer. Elle a cependant conservé une partie de sa nature animale. Cuvier, Animaux fossiles. Tome 4, Crocodile fossile. Page 17 and 18. Some examples have large foramina for the passage of blood vessels. I may perhaps be accused of indulging in the marvellous, if I venture to state that upon comparing the larger bones of the Sussex monitor with those of the elephant, there seems reason to suppose that the former must have more than equalled the latter in bulk, and have exceeded 30 feet in length, and yet some fragments of bone in my possession warrant such a conclusion. The teeth near the front of the lower jaw of the barracuda are very similar in form, on the authority of Mr. Clift. The markings on its surface resemble those of the dorsal scales of the sturgeon. Mr. Clift. The analogy which they bear to those of Purbeck. The Purbeck beds occupy the highest place in the oolite series and consist of thin strata of argillaceous limestone, alternating with schistose marls, forming an aggregate of more than 300 feet in thickness. The fossils of the Purbeck stone consist chiefly of shells, which are supposed to resemble freshwater species, as the vivipare, cyclostome, planorbis, etc., impressions of fish, bones, and plates of one or more species of turtle, and the bones and teeth of an animal of the lizard tribe, allied to the crocodile. The circumstances under which these strata appear differ greatly. They are distinctly seen in the Isle of Purbeck, and form a considerable district in Yorkshire, called the Vale of Pickering. The same strata appear in Kent, rising together with others from beneath the chalk, where from the coarseness of the limestone it has been called the Kentish rag. Phillips' Outlines of Geology. No detailed account has yet appeared before the public. In the second part of the 5th volume of the Geologue Trans just published, Mr. Conybeare states that Professors Kidd and Buckland have been long engaged in the study of these interesting remains, and it is expected will shortly publish the result of their observations. According to Dr. Kidd, Geological Essays by J. Kidd, M.D., 8 volumes, 1815, page 38. Highly interesting memoir on the Plesiosaurus. Geological Transactions, Volume 5, page 592.